Hello everybody, welcome to my channel Math Insights. In this video, we are going to discuss some more concepts on sets, relations and function. See, I am making this video as part 2 content. Why? Because in the content video, we will discuss the concepts only. Then we will have another video. In that video, we are going to solve problems based on the concepts which were discussed. Shall we? In the previous video, we discussed number of definitions in sets. Based on those definitions, we are going to do some operations on sets. So these are the main operations. The first one is union of sets, intersection of sets, difference of two sets, complement of a set, and finally, very important also, symmetric difference of two sets. If you see the first operation on sets, union of two sets. The union of two sets is the set which contains the elements of either A or B or A and B. I will explain it by taking a simple example. Suppose if A is equals to 1, 2, 3 and B is equals to 2, 3, 4, 5. Now I want to do the union of these two sets. Union of two sets is represented as A union B. This U is from the word union. So you are writing A union B. That is equals to, as per definition, the union of two sets is the set which contains either the elements of A or B or both. Now if you see, I am taking the elements of A only. That means you have one only, which is the element only in A. And if you see, this 4, 5 are only in B. And after that, if you observe, these 2, 3 are in both A and B. So I am writing a set with elements of either A or B or both. See, you may write the element 1 in the first place or the last place. Why? Because there is no preference for the order of any element in a particular set. If you write it in first place or the last place, it will not make any difference. Therefore, A union B may be written as 1, 2, 3, 4, 5. This is also same as before. And if you write A union B in set builder form, you know very well what is meant by set builder form. Set builder form is a process, a method which is written by taking property of all the elements instead of writing all the elements. See, I have written all the elements, but instead of that, I will put a name to all those elements and I will explain where X is. So, X belongs to A or X belongs to B. This is the way how to represent A union B in set builder form. If you see the next operation, that is intersection of sets. So intersection of sets means if A and B are two sets and then the intersection of two sets A and B is a new set which contains the elements of both A and B. Both A and B. Suppose if I take A is equals to 1, 2, 3, 4 and B is equals to 3, 4, 5, 6. A and B are the two sets which contains 4 elements in each of them. Now I will represent A intersection B by writing inverted U. In the case of union, you have written U. But here for intersection you have to write inverted U, that represents intersection of two sets. Now intersection of two sets, as per definition, the elements of a set which contains both elements of A and B. If you see 3, 4 is in A and 3, 4 also in B. So 3, 4 are common to both A and B. Therefore, we will take those elements, and those elements comes under intersection of A and B. Therefore, 3, 4. We will leave these elements and these elements which are only in A and B. So this is the intersection of two sets, and you may represent intersection of two sets with set builder form as X such that, you will read it as such that I am giving a name to all elements in the set A intersection B, and then I will write the property or where they are. See, X is an element which is in A and B. You have to write X belongs to A and X belongs to B. Those elements are taken into count in the set A intersection B. Coming to the third operation, difference of two sets. If you take two sets A and B, then its difference is represented as A minus B. A minus B, that is equals to, it says that difference of A and B is a new set which contains the elements of only A, and we have to remove the elements of B if any are there in A. I will explain it with example. Suppose A is equals to 1, 2, 3, 4 and B is equals to 3, 4, 5. If we want to do the difference of two sets, I will first represent A minus B. That means that is the difference of two sets. I will write the elements of only A, and you have to remove the elements of B if any are there in A. See, if you observe 3, 4 are both in A and B, therefore I will remove this 3 and 4 and I will write the elements of A only. Simply I am removing B. Therefore 1, 2 is the set which says that A minus B. A minus B, the difference of two sets may be represented in other ways also. A difference of B, this symbol represents difference of two sets, and also A slash B, actually this is written as like that, this is called slash, but you should not write on that slant, you have to write like this. This is called A minus B, difference of two sets. If you come to the fourth operation of sets, complement of a set, you know very well what is meant by complement of a set. Here you have to discuss the set universal. Universal set is a bigger set, and all sets are subset to the universal set. You know, universal set generally represented as mu or u. If you see this mu or u, you have to understand that that is a universal set. If you take any set and if you want to find complement of it, suppose I am taking a set A, then its complement is represented as A dash. We will read it as A dash or AC, that means complement of A. So in this way you may represent it, and you define it as A dash is equals to mu minus A, difference of the universal set and the set which you want to find its complement. And if you want to find B dash, that is equals to mu minus B. In this way you may find complement of any set. I will explain it with an example, then it will clear very well. Suppose if mu is equals to 1, 2, 3, 4, 5 and A is equals to 1, 2, 3, then the complement of A is written as A dash, that is equals to mu minus A. That means you have to write the elements of mu, that means 1, 2, 3, 4, 5 minus elements of A, that means 1, 2, 3. You have to remove, minus means subtraction, you have to remove all these elements from this set. That means you have to remove all this, and then 4 5 will remain, and this is called complement of set A. In this way you may have more examples in our coming videos, problem solving video. Next and last operation in this operations is symmetric difference of two sets. Suppose if you take two sets A and B, its symmetric difference is represented as A union B minus A intersection B, or A minus B union B minus A. This is the symmetric difference of two sets. It is represented as A delta B, A delta B. Here also A delta B. In another way also you may represent it. A, you have to write plus and circle A symmetric difference B, otherwise symmetric difference of A and B. It is defined as A union B minus A intersection B. You know how to find A union B and A intersection B, and also you know how to subtract a set from another set. In this way you may find symmetric difference of two sets. I will explain it by taking one example. Suppose if A is equals to A comma B comma C and B is equals to B comma C comma D. First, if you want to find symmetric difference, you have to calculate A union B and A intersection B. A union B is equals to the elements of in A or B are both in A and B. That means A comma B comma C comma D, and A intersection B. A intersection B is a set which contains common elements of A and B. If you see, B and C are common, therefore I am writing B and C. After finding A union B and A intersection B, you have to find the symmetric difference of A and B. That is, the formula is A union B minus A intersection B. I will write the set A union B, A, B, C, D, A comma B comma C comma D, minus A intersection B. A intersection B is the set which contain the elements B and C. So if you subtract B, C from these, then you will get A comma D. This is called symmetric difference of A and B. In the similar manner, if you do in this way also, first doing A minus B and second B minus A, and then if you do this operation union, you will get the same answer. We discussed important operations on sets. After those operations, you have to know some representations and notes. Very important all this. See, the first one is, if you want to do the union of more than two sets, let the sets be A1 comma A2 comma A3 and so on n. I am taking n sets. Then its union is represented as A1 union, A2 union, A3 union and so on union An. Simply, if you want to write it, you have to write union Ai. That means where I is equals to 1 to n. If you replace I is equals to 1, you will get A1. If you replace I is equals to 2, A2 and so on. If you replace I is equals to n, you will get An, and between them you have to put the symbol union. Then that will become the union of more than two sets. Similarly, intersection also. So intersection Ai, where I is equals to 1 to n, you may represent simply. And you know that A union B is equals to B union A. If you do A union B, you will get the same set as B union A also. Similarly, A intersection B is equals to B intersection A. Coming to second note, if you take two sets called A and B, then A minus B, the difference of A and B is not equals to difference of B and A. You have to keep in your mind, this is very important. A minus B and B minus A are very different sets. So I am going to say then in the next point, A minus B, B minus A and A intersection B are disjoint sets. Disjoint means they should not have any joint elements, means they should not have any common elements in them. So A minus B, B minus A intersection B are different. They do not have at least one element in them as common. That's why you will call A minus B, B minus A intersection B are disjoints, and also you are writing A minus B is not equals to B minus A. Similarly, A minus B, the set, is subset or equals to A. B minus A means you are removing A and writing the elements of B only, then that will become subset or equals to B. You know what is meant by subset in the previous definitions. And finally, the third note is a symmetric difference between A and B is equals to symmetric difference between B and A. These are very important in solving the problems. Next, we are going to discuss some laws or theorems of sets. All these laws you know very well: idempotent law, identity law, commutative law, associative law, distributive law, De Morgan's law. All these laws are very familiar in algebra. In algebra, we will use addition and subtraction and do those operations. Here, instead of addition and subtraction, we will use union, intersection, subtraction, everything on the sets. Then we will apply all these laws to sets also. First law is idempotent law. Idempotent, potent, the name potential. That means if you get the same set by taking the set, suppose I am writing the first is A union A is equals to A, and A intersection A is also A. That means you are getting the same set by using the set. This is called idempotent law. You may have this proof by taking some elements, whatever you like. You will get the same set on both sides. Coming to identity law. In algebra also you have identity law and identity element under addition and under multiplication. Identity element under addition is 0 and identity element under multiplication is 1 in algebra. In the similar way, you have identity sets. So in identity law, we will say that A union pi is equals to A union pi. That means if you combine pi and A, you will get A. And also A intersection pi. That means if you want to take the common elements of both A and pi, you don't have the common elements. That means you will get pi. And also A union mu. You know what is meant by mu. Mu is universal set. If you combine mu and A, you will get mu. And also if you do intersection with mu, that means you are taking the common elements of both A and mu. Mu is bigger set, you know, and you will get A again. These are called identity laws on sets. A union pi is equals to A intersection pi is equals to pi. A union mu is equals to mu. A intersection mu is equals to A. Very simple. And coming to commutative laws, you know, in algebra also we have commutative laws. Suppose A comma B are two real numbers, then A plus B is equals to B plus A, and also A into B is equals to B into A. Similarly, you have commutative law in sets. Instead of plus and minus, we will use here intersection and union. So if you take two sets A and B, then its commutative law is written as A union B is equals to B union A. Similarly, A intersection B is equals to B intersection A. That means instead of writing in first place, you may write it in second place also. You may get the same answer in both cases. These are called commutative laws under intersection and union of two sets. Coming to next one, associative law. So in associative law, instead of taking two sets, we will take three sets. If A, B and C are three sets, then its associative law is written as A union B union C is equals to A union B union C. Similarly, A intersection B intersection C is equals to A intersection B intersection C. That means if you observe the first one, you are taking B union C as a set and A as a set, and if you combine these two sets, you will get the same set after combining A and B first instead of B and C, and again combining with the C, you will get the same set. So if you change the operation, union is changed to intersection, then you will get the same answer. These are the two associative laws. Coming to distributive law, it's very important. In algebra also you have distributive law. So instead of taking one operation, either plus or minus, we will take both operations, plus and multiplication. So in similar manner, in sets also, in associative law and commutative law, you have taken union or intersection. But in distributive law, we will take union and intersection at a time, then we will write the distributive law. If A, B and C are three sets, then distributive law may be written as A union B intersection C is equals to A union B, okay, intersection A union C. And I will change the operation, simple. If you know this, you can write the second one. Instead of union, you will write intersection B union C is equals to A intersection B union A intersection C. These are the two distributive laws. In these two laws, we will use union and intersection at a time instead of using union once and intersection once in commutative and associative laws. Next and last important law is De Morgan's law. De Morgan's law, in De Morgan's law, if A, B and C are three sets, then De Morgan's laws are A minus B union C is equals to A minus B intersection A minus C. This is the first De Morgan's law. Very simple. You have to apply this minus to the sets B and C. But after application, this union will become intersection. Keep in your mind. And also second one is A minus B intersection C. Very simple. If you know this one, you can write this very easily. So A minus B, so intersection will become union and A minus C. You are distributing this A to both B and C. Therefore A minus B, this intersection will become union and A minus C. And third law is A union B whole dash is equals to A dash. Dash is nothing but complement. Complement of the set A union B, that is A dash intersection B dash. Very simple. In complements, this union will change into intersection. Similarly, if you come to the fourth one, A intersection B whole dash is equals to A dash union B dash. These are the four De Morgan laws on sets. Basing on all these laws, we will solve the problems in problem session. If you like my video, please subscribe my channel and don't forget to press the bell icon. This gives me encouragement and I will do more videos on important topics. Until then, have a nice day. Thank you.